Close your eyes for a moment. Imagine yourself standing in the vast Arctic wilderness where the wind whispers through endless fields of snow. The air is crisp, the world is silent, and before you lies an ancient challenge: building a kugik, an igloo, a perfect shelter against the elements. This is a skill honed by the Inuit for centuries, a remarkable feat of engineering and survival. It's no different from an architect carefully selecting materials and blueprints before constructing a skyscraper. Each step must be precise, each element working in harmony. Let's explore, step by step, how the igloo is crafted by the Inuit. The first step in building an igloo is selecting the right location. The snow must be firm and compacted. Light, powdery snow won't hold together. A gentle slope can provide extra insulation, but a flat open area allows for easier construction. The ideal spot is one where the snow has been naturally compressed by wind, forming dense blocks that can be cut and shaped with precision. This type of snow is known as pukak, and it is the foundation of a well-built igloo. To test the snow, Inuit builders use a pana, a snow knife crafted from bone or metal, or a modern snow saw. These tools slice through packed snow as cleanly as a sculptor's chisel through stone. The snow should resist crumbling and hold its shape when pressed. Areas prone to sudden drifts or high winds should be avoided to ensure longevity. Once the location is chosen, the builder must clear away loose surface snow, revealing the compacted layers beneath. This is similar to a construction crew clearing debris before laying the foundation of a building. Once the location is set, large blocks of snow must be carved with precision. The Inuit traditionally use a pana to cut each block from the snowpack. These blocks, called ovik, should be approximately 3 feet long, 1 foot high, and about 8 inches thick, proportions that ensure stability and ease of stacking. Cutting the ovik requires a practiced hand. The builder carefully marks each block before cutting, ensuring uniformity. In the same way that a mason inspects bricks for consistency, an igloo builder taps each block lightly to check its density. Blocks are lifted with care to prevent fractures, much like handling fragile tiles during construction. Each block is then arranged near the foundation site, ready for placement. Inuit builders often use a method called kamik, or testing the snow's moisture content, to determine how well the blocks will bond together. If the snow is too dry, the blocks may crumble under pressure. If too wet, they may become too heavy and collapse. The selection of snow is as vital as choosing the right materials for a modern skyscraper. Experienced builders know to cut blocks from an area where the wind has naturally compressed the snow, making it firm yet workable. Once the blocks are extracted, they are stacked nearby in an orderly fashion. Much like a bricklayer organizing materials before constructing a wall, this step ensures efficiency when assembling the igloo. The blocks must be handled gently, as even the smallest fracture could weaken the overall structure. The first layer of an igloo is its foundation, a circle of ovik placed at a slight inward angle. This inward tilt is critical. Without it, the igloo would lack its characteristic dome shape and collapse under its own weight. This method has been passed down through generations, refined over time through trial and experience. Imagine assembling a jigsaw puzzle where each piece must fit seamlessly. The ovik are carefully shaped to remove any excess edges, and gaps are filled with loose snow, acting as a natural adhesive. Before moving forward, the builder steps back, ensuring the ring is symmetrical. This step is comparable to laying the first course of bricks in a wall. If the foundation is uneven, the structure above will be unstable. The precision of the first layer is crucial. The builder often walks around the circle, testing the stability of each block. If a block wobbles, it is carefully reshaped with the pana before continuing. Much like laying the cornerstone of a building, any imperfection in this stage could affect the entire structure. To create a seamless base, the edges of each ovik are beveled slightly, allowing them to interlock more securely. Builders may even place their weight on the first few blocks to compact them further, ensuring they hold their shape under pressure. The importance of this step cannot be overstated. It is the true foundation of the igloo's strength. Now comes the most delicate and rewarding part of the build: constructing the dome. Unlike a simple stacked wall, an igloo rises in a continuous spiral. The technique used is brilliant in its simplicity. Each block is slightly smaller than the one below it, gradually creating the dome shape. This method is similar to how ancient civilizations built domed structures like the Pantheon, carefully balancing each layer to distribute weight evenly. As each row is stacked, the builder carves slight angles on the edges of the blocks, ensuring a snug fit. Snow is packed into any small gaps, reinforcing the walls. The precision of each cut is as important as the measurements used in modern architecture, ensuring strength and longevity. One of the most remarkable aspects of igloo construction is the self-supporting nature of the dome. Unlike square buildings that rely on vertical support beams, the igloo's weight is evenly distributed across the structure. This is why each block must be cut at just the right angle. Too steep, and the structure will collapse inward. Too shallow, and the dome won't form properly. Inuit builders rely on centuries of knowledge, often using sight and feel rather than strict measurements to perfect the angles. As the walls rise, the spiral pattern becomes more evident. Unlike traditional homes with distinct walls and roofs, an igloo is a single, unified structure. The builder carefully ascends as they work, using existing snow blocks as makeshift steps. Some Inuit builders even shape temporary footholds in the inner wall, allowing them to reach the upper layers with ease. Each block is placed with precision, much like constructing a cathedral dome, where every stone plays a role in holding up the whole. At the very top of the igloo, the final block, the keystone, is carefully cut and placed. This block is crucial, as it locks the entire structure into a self-supporting dome. Without it, the igloo would remain incomplete and vulnerable to collapse. The principle behind the keystone is similar to the design of an archway or bridge. It must be cut to fit the exact shape of the remaining gap. Builders often trim the block several times, making small adjustments until it fits perfectly. Once set in place, the entire structure tightens, and the pressure is distributed evenly across the dome. This is more than just the completion of a building. It's the moment when everything comes together, a test of craftsmanship, and a satisfying final touch to the igloo. The keystone is symbolic too, signifying the balance between human skill and nature's forces. Once it's placed, the igloo stands strong, a testament to both engineering and tradition. The entrance to an igloo is far more than just a simple doorway. It's a tunnel carefully crafted to help retain warmth and keep out the cold. The design is ingenious. By lowering the entrance below the main chamber, cold air naturally sinks, while the warm air stays inside. Imagine it like the design of a modern, energy-efficient home, where airflow is key to maintaining temperature. The entrance is carved as a small passage, extending outward and downward, so that even on the coldest days, the interior stays warm. Some builders take it a step further, creating an extra layer of protection, an internal dip in the tunnel that helps trap the cold air before it can enter the living space. This clever design acts much like modern insulation, creating a shield that keeps the igloo comfortable, even in extreme Arctic conditions. The final steps involve refining the interior. The inner walls are carefully smoothed to prevent condensation. Any sharp edges or protrusions are shaved down, ensuring even heat distribution. A small air vent is carved at the top to allow airflow, preventing the buildup of carbon dioxide from human breath. Over time, the heat from occupants and a small flame slightly melts the interior snow, which then refreezes, reinforcing the walls. This process is similar to modern construction methods that use controlled moisture levels to strengthen materials over time. Additional refinements may include an ice block window for light or raised sleeping platforms made of compacted snow. These platforms help separate the sleeper from the cold ground. Much like an insulated bed frame prevents cold drafts, The igloo is more than just a shelter. It is a marvel of natural architecture, built from nothing but snow, yet capable of withstanding the harshest Arctic conditions. For centuries, the Inuit have relied on this skill to survive and thrive in extreme environments. Today, this knowledge remains a testament to human ingenuity and adaptation. Just as modern engineers create resilient buildings using advanced materials, the Inuit have mastered the art of using their environment to their advantage. The igloo is not only a structure of survival, but a symbol of human creativity. Whether for survival, cultural preservation, or simply an appreciation of ancient craftsmanship, the igloo stands as a remarkable example of what can be achieved with skill and knowledge. Thank you for joining this journey into the art of igloo building. Until next time, stay warm and adventurous.